So now we want to be able to take a picture of an original function and graph the first derivative. This is not an easy task, and it's something that we need to practice a lot. So here we have an original function. This is where we're going to do our analysis. On the right-hand side, you can see a graph of the first derivative in red, but we have to figure out how we go from the blue graph to the red graph. It's always easiest to start with the zeros of the graph. So to look for places where we should have horizontal tangent lines. So here we're changing from increasing to decreasing in 3 places. So this happens at -1, 0, and 1. So at -1, 0, and 1, the derivative has a value of 0, which means it's going to cross through the x-axis. Now, once we have our zeros in place, we need to look at what the original function is doing in terms of increasing and decreasing to determine if the derivative is going to be positive or negative. So we read graphs from left to right. So for f of x, the first chunk from approximately -2 to -1, this part right here, is decreasing. Since it's decreasing, that means that my derivative function needs to be negative. And that means it needs to be below the x-axis before my 0. So remember, I got to go through 0 here at -1. But before that, I have to be below the x-axis. So since I have to be below the x-axis and I need to go through that 0, I know that I have to be moving in the upward direction. Now, between -1 and 0, we are increasing. So when we're increasing, that means we have to be positive. So my derivative has to be above the x-axis between -1 and 0. Additionally, I know that I have to go through the axis at -1 and again at 0, which means to be above means I'm going to have to turn around to be able to get back to that 0. Now, from 0 to +1, I'm decreasing again. So if I'm decreasing, I'm below the x-axis, and I have to get from 0 to 1, and I have to go back through the 0, so I have to turn around. And then finally, from 1 to 2, I again am increasing. And if I'm increasing, I need to be positive or above the x-axis. So where I have to be is really important. The more we practice this, the better we get at it. Another thing we want to consider as we move along is using some slopes of tangent lines to get more accurate depictions of where our graph should be. So for example, I can see that my graph turns around right here, which looks at like it's approximately 1.5, right? So if I want to approximate where that maximum is, I need to consider what's happening at approximately -0.5. So if I go to my original function and I go to -0.5, I'd want to approximate the slope of the tangent line at -0.5, which is something we were doing earlier today. So I would draw on the tangent line, I'd find 2 points on that tangent line, and I'd approximate the slope of that line. And when I did, I would approximate that it was approximately 1.5. So that's what would tell me how high to go. I could do the same thing by approximating how low I would go between 0 and 1 by approximating the slope of the tangent line at +0.5. So here, if I were to draw in that tangent line, I'd pick 2 points on that line, and I would get approximately -1.5, which would tell me that my function, my derivative function, would need to go that low. So I can get actual points by using the methods we discussed earlier. But for now, I want to get a general sense of above and below, and then we'll refine it a bit as we practice. Example 6. Graph the first derivatives based on the function below. So we're starting with a function that has a U shape, and we want to get a general sense of what the derivative is going to look like. We're not going to do this precisely and exactly yet. We're going to do this in a general sense. We'll refine it a little bit more once we get to 2.4. We'll refine it a little bit more as we continue to practice. So again, the first thing we want to do is we want to draw in our zeros. So we're looking for horizontal tangent lines. So at x equals 0, we have a horizontal tangent line, which means when we draw our derivative graph, that when x equals 0, the derivative equals 0. Now, from what I learned before, if my function's decreasing, then my derivative should be negative. And if it's increasing, my derivative should be positive. So here, if I read my graph from left to right, it starts off decreasing. So it's moving downward from left to right, which means I need to be negative before my 0. As I move away from 0, I can see my function is increasing, which means that my function needs to be positive as I move away from 0. So now let's think about how this function is going to travel from below the x-axis to above. In order to do that, let's think about what these tangent lines are doing and what they look like. So let's draw in some tangent lines here. Looking at these tangent lines, the slopes are all negative, and those negative slopes are getting less and less steep. So if we were to assign a value to those, they would be getting closer and closer to 0. They would be becoming less and less negative, which means that my function that I'm drawing, my derivative, is increasing. Similarly, when we draw in some tangent lines to the right over here, these values are positive, and they're getting steeper and steeper, which means the y values are getting bigger and bigger. So my derivative has a general function that's going to come up through the 0 in an increasing manner. If I wanted to be more precise about it, I could extend my tangent lines, find 2 points that they cross through, and get the exact number. But for now, I'm still getting comfortable with the general pictures. Let's take a look at another one. This one is similar to the last one. The last one was a U shape. This one's a hill shape. I want you to take a minute and mentally try to envision what you think the derivative is going to look like based on the fact that the last one was the same exact graph but rotated. What do you think that's going to do to the derivative? So again, we want to start with the zeros. So again, at x equals 0, we have a horizontal tangent line, which means we're going to go through at 0. And then we want to look at what the function is doing from left to right. Our function starts off increasing. If your function's increasing, that tells you that the derivative is positive. And then our function changes at 0 and starts to decrease. If your function's decreasing, that tells you that your derivative has to be negative. Again, considering what the slopes are doing of these tangent lines, we can see that they start off positive but come down towards 0. And then once they reach 0, they become negative and more negative. So we have a decreasing function for our first derivative as we move through our 0. So these two shapes, the U and the hill, comprise most of the functions we look at. There's various U's and hills. So having a basic understanding of what the derivative will look like for these functions will help us build derivatives for more complicated functions as we progress.